Ladies and gentlemen, we will start our first lecture in the second phase of Lean Six Sigma project, the measure phase. In the define phase, we came up a set of ideas from VOC, the CTQ critical to quality parameters, brainstorming, affinity, etc. All the ideas will be used for identifying issues in the organization. Therefore, it will be given top priority in data collection and measurements. Such key process steps will be measured, for example, flow rate, inventory level, cycle time, defect rate, etc. Data about those parameters is then gathered and analyzed. The current state of the process will be fully described by the measures, and a current state map is developed. These ideas can then be evaluated and formalized into project charters, which will allow to priorities for implementation. Again, in measure phase, the following tasks will be done: measure key process, collect and analyze data, identify the vital few that have greatest impact, estimate process capability, measurement system analysis. The following topics will be covered in details during 8 lectures: data collection, check sheets, sampling techniques, sample size, input-output, XY, analysis, Pareto analysis, measurement system analysis, MSA, process capability, sigma level, spaghetti diagrams, value stream mapping using iGraphX and Minitab. The module includes the following documents for download: the course material in PDF, templates for Pareto analysis, process sigma, process capability, sample size, takt time, XY analysis, gauge R&R analysis, and takt time calculator. Minitab examples for measurement system analysis, Pareto chart and process capability. iGraphX, example for value stream maps. Instructional videos for measure phase using Sigma XL, and measure phase templates, measurement system analysis using Minitab, Pareto chart using Minitab, process capability using Minitab, sample size using Minitab, and value stream mapping using Minitab. Before going details of data and measurements analysis, we have to practice the Data Analysis tab in Excel. The Analysis tool pack includes the tools described in the Measure Phase lectures. To access these tools, click Data Analysis in Analysis group on the Data tab. If the Data Analysis command is not available, you need to load the Analysis tool pack add-in program. Click the File tab, click Options, and then click the Add-ins category. In the Manage box, select Excel Add-ins, and then click Go. In the Add-ins box, check Analysis Tool Pack checkbox, and then click OK. If Analysis Tool Pack is not listed in the Add-ins Available box, click Browse to locate it. If you are prompted that the Analysis Tool Pack is not currently installed on your computer, click Yes to install it. In order to study the data collection, we must first understand the two types of data and difference between them. First type is continuous data. It is any variable measured on a continue or scale that can be infinitely divided. For example, lead time, cost, price, time, height, weight, density, or temperature. Second type is discrete data or attribute. They are either count or percentage, or data that has one of two values. For example, on-time delivery, yes or no, acceptable product, pass or fail. Attribute nominal, name or label, for example, machine 1, machine 2. Attribute ordinal, name represents a specific value. For example, on product performance, excellent, very good, good, fair, or poor. Example for continuous data: time, temperature, cost, weight, distance. Calculated data. Example for discrete data: attribute, number of complaint per week, number of defectives per test, job completed on time or delayed, manufactured items, accept or rejected. Example for continuous data from manufacturing: cycle time, efficiency. For discrete data from manufacturing: number of defect. The goals from data collection plan are: describe the data collection in overview, which data is to be collected, how, when, and by whom. Lay a foundation for the accurate collection of all relevant measurements. And the steps are: 1. Draw up the operational definition. 2. Determine the data sources and type. 3. Devise the sample strategy. 4. Develop data collection forms. 5. Carry out the measurement system analysis. 6. Collect the data. 7. Depict the data in graphs and charts. Example of data collection plan. We will measure the coloration. The type of measurement will be output. The type of the data will be discrete. The operational definition of the data is that the finished vehicle is inspected. The undercoat, paint, and varnish are applied and have dried. The results that gauge R&R is 90%, and after rework, it will be 100%. How to do the data collection or measurement during visual inspection in the workshop: it will be under full lighting capacity, and also, no difference between old and new paint applications must be visible. The operator will do the measurement. He will do it every second job between January 27, 2021 and February 14, 2021. He will do it in spray or painting of the vehicle. The check sheet is a simple document that is used for collecting data in real time and at the location where the data is generated. The document is typically a blank form that's designed for the quick, easy, and efficient recording of the desired information, which can be either quantitative or qualitative. When the information is quantitative, the check sheet is sometimes called a tally sheet. Types of check sheets: basic check sheet, frequency plot check sheet, traveler check sheet, location check sheet, graphical check sheet. Basic check sheet is easy to make and use. Simply list the problems you're tracking and leave space to allow marks whenever someone finds that problem. The example shown here also includes a time element. An example for car dealer: tally sheet for internal rework in the paint shop. The sheet shows the reason, the frequency, and remarks. Another example for motor assembly check sheet. Another example shows the job number, closing data, customer service employee, and the reason. Frequency plot check sheet automatically shows distribution of items or events along a scale, or the order quantity. It helps detect unusual patterns in a population or detect multiple populations. It gives visual picture of average and range without any further analysis. An example for frequency plot check sheet, the complaint repairs in a specific date. Traveler check sheet is a check sheet that travels with a work item, product, form, etc. At each process step, the operator enters the appropriate data. Good way to collect data on process lead time. Data collection sheet based on a physical representation of a product, workplace, or form. Data collectors enter marks where predefined defects occur. Allows you to pinpoint areas of defects or problems and therefore focuses further data collection efforts. An example of location check sheet, reject shirts check sheet. An example of a location check sheet for the defect location in a gear. Graphical check sheet includes when the data has been collected, and it represents an x-axis and y-axis. To gather data on the reasons for customer complaints about a new produced dishwasher, a team at the quality department should develop a check sheet. The check sheet should include all the necessary data to determine the main issues in the new product and determine if the manufacturer needs to design another complete new product or just modify the current product. Please develop the required check sheet. Please perform the activity and send your output by email for assessment. Thank you, and see you in the next lecture of the measurement phase.